Almost. Okay. All right. Since I know everyone here should know what's going on right now, so let's see if you guys are ready. All right, you guys ready? Hey, are you ready? Are you ready? No? You're not ready? You are, class. Okay, class.
Yes.
Thank you. Thank you. Okay, Rigo, where were you on that one?
What do you mean? I said it this morning already. I can't say it twice.
You gotta say it twice. Now, you're taping it wrong.
How?
You're taping it wrong. Look, you're teaching students the wrong thing. How are you supposed to tape it?
Oh, yeah.
See? Bad, Rigo. Bad. No. Yes.
No, it's not even.
Hey, you need two of those?
Yeah, this one ripped.
Oh, okay. All right. Now, for those people following along at home and all those other people in class that are finally paying attention. Now, Rigoberto, what page are we on in this nota book?
Right? 6,
7.
7. Oh.
This one's 7. Because the last set of notes that we did were on page 5, right? I know you weren't. So where do you think you're going to find the notes if you weren't here for it? Okay, you know you're going to screw this up again. Okay, bruh, it goes here and here.
Oh my god.
Otherwise it falls out.
I might as well just take the whole thing.
No.
Why?
No, because you need to be able to get to the other side. Okay, so before I get demonetized again because Rigo, we're going to go through and talk about pairs. So pairs of circles and common tangents. You had one of these problems on yesterday's practice, but it wasn't in the notes. But I did mention it because that last question was talking about, it was like internal tangents and external tangents. So, yeah, they're on today's notes. They were supposed to be yesterday, but I guess not. Anyway, here we go. Okay, so two circles are congruent circles if and only if they have congruent radii. Now, can someone tell me what the word congruent means?
Hey Siri.
Same measure. Hey Siri, how many years would I get for punching Rigo in the face?
Yo.
No.
60
Oh,
years.
none?
60
None? Oh, good job, Siri. Yes, because I'm doing the government a favor.
No, you're not.
Anyway, it have to have the same measure. So the radii from the center of the circle out to the edge is going to be the same. Circles are going to be congruent if they have the same measure and if the radius are the same. Does that make sense? No?
Yeah.
Why is this guy so mouthy? He always like that? Okay, you, that guy.
I just got added to his class.
Why'd your earbud in there? See. All right, good. Okay, thank you, appreciate it. Now, concentric circles are coplanar circles with the same center. Now, we're going to have two different sized circles that have the same center. It's kind of like a donut. Okay, we have an outside circle and we have an inside circle. So in this one right here, concentrics, it's one inside the other, and they both have to have the same center of the circle. Next one is going to be two coplanar circles that intersect at exactly one point are called tangent circles. So they have to intersect somewhere. That means they have to touch. This was our example that we had yesterday. Okay, it said internal tangent circles, but on yesterday's practice, there wasn't one that matches it. External, they are touching each other at a single point, just like that right there. So they're outside of each other. Does that make sense? All right, questions? Super easy, right? Okay. All right, let's see if you guys remember this from yesterday. So in these ones right here, we're going to go through and fill it out. And if I see someone checking the phone again, like, you know, thank you. Then, I don't know why you're trying to check the time, because you ain't getting out of here. You ain't. Okay. Really? You're still with it? Can't look at it. Seriously.
Yo.
It hasn't changed. Hasn't changed since this morning. Okay. Use a graph to identify each of the following. Radius of R. Okay? Radius. That means from the center out to the edge. Circle R. Let me see. Use the hair. What is the radius of circle R? I don't know is not the correct answer. Try again. How do you think you'd figure out? What is radius?
The same thing.
The same thing? Nope, try again. What is a radius?
Like the area.
Nope, try again.
The perimeter.
Nope, try again. It's almost like there was a definition that we talked about yesterday, but some people wanted to sit in the very back but not actually do anything. What is the radius? No, it's not bro. Try again. Dude, I know you know how to read. What is the radius? Radius is from where? Okay, from where? Okay, endpoint where? Endpoint to the center, right? Okay. So, from the center to one of the edges, right? Okay, so now, back to my problem over here. So, we're looking at R. Where's the center of R? Probably right there where the red dot is, right? Where the letter R. Radius, how can I figure out the radius?
Count it.
Perfect, count it. Can you count it for me, please? That's all I was asking for.
No.
What, how many did you get?
3.
He said 3. You sure? So, we're going from here to the edge, right? You ready? You ready to count with me? You ready? 1. So what's the radius? 2. So my radius of this one, so R equals 2. Now, if you notice, give me, I don't know, it's not a good thing. Okay, and I just keep going. If you were to just give me an attempt at an answer, then I could probably help you with it. Okay? I really hate I don't know, because I know you know something. You might not know the answer, but you could attempt. Make sense? So, otherwise, then you end up like this thing over here. Okay? You don't want to be like this thing over here. Okay? All right, next one. So, let's go down.
Center of R.
Center of R. Rigoberto, thank you.
Oh, here it's 6.
I know you weren't.
Let me go back to my notes.
You don't need to go back to your notes because it's on the screen. See right here where this red dot is?
Yeah.
Okay, where is this red dot at? Just give me the coordinate. Just ask for the coordinate.
Like the way it moved? Like
Yeah.
2.
So it is,
12 to 3.
it's to left 2, right? So if it left 2, what does that mean?
Okay. No, negative.
Negative. So it's a negative
Negative
2, comma, is it down 2?
Yes.
It's down 2, so that means it's going to be negative 2.
Oh.
So the x value is negative 2 because it goes left 2, right? And the y value is down 2, so it's also negative 2. Okay, does that make sense?
Yeah.
You feel better about it now? Yeah, see? Now you got this. Okay, let's see. Radius of S.
1.5.
1.5. Hey, good job, yes. 1 and 1/2. Because it's about that. So from here, 1 and about 1/2. So my radius is 1.5 or 1 and 1/2 if you want to have a fraction. Because fractions are your friends, not food. Center. Center. Okay, you ready? Talia? What's the coordinate for the center of S? So x value first. What's the y value? 1 and 1. Yep. Okay, there we go. So center of S is going to be negative 2 is my x, and the y value, it's up 1.5 or 1 and 1/2. Yes, no, maybe?
Yeah.
Possibly. Possibly, yes. Okay, so now point of tangency. This goes to a definition that we had. Point of tangency, Thanos. Point of tangency. Do these two circles touch? Yes, they do. At only one point, right? At a single point. What is the coordinate for that single point? -2 and 0. Perfect. Good job. -2, 0. Now, next one is common tangent, is a line that is tangent to two circles. So here is different examples here. Now, going by my examples, the tangents, look at the tangents there. So what you guys are going to do, you guys are going to do your best on this one right here. So, common tangents. So, is this first pair of circles, do they have a common tangent?
No.
Yes.
Yes, they do.
What?
Yes, they do.
They touch.
Do they touch?
Yeah.
Oh, nothing.
So they have a point of tangency, don't they?
Yeah.
Okay.
About a different way. Never mind.
Okay, we have that too. We have that too. So we would have a point right here is my point of tangency. And now, from here, we're going to do, where's mine? Rigo, what'd you do with that stick I used to slap you with?
Yo, what?
Okay, so I'll use this. Now, this one doesn't work. So I'm gonna have to do my best here. Anyway, so I could do also touching like this. Oh man, that is like horrible. But pretend like it's touching right there.
Oh,
And then I could do the same thing down here, can't I?
no.
Yeah. So I can do the same thing right here, but again, my penmanship is horrible. So I apologize for that. Is that pretty easy there? The second pair of circles. Do those have common tangents?
No.
Yes and no. Yes and no. Okay, I could have a tangent line. The tangent line on the outside, but what's wrong with these? What's wrong with these two right here?
They're intersecting.
They're not just intersecting, they are overlapping. They don't have a point of tangency. The point of tangency means that they would touch it only in one place. That guy's trying to get your attention. That guy right there. Gracias. Okay, good. So, I know you guys are drawing the lines like that, right? What about these two right here? The next set of circles. Next set of circles. What type of circles those are? Yes?
I have a question about the previous one. Wouldn't like the two parts that are overlapping be a point of tangency?
It would not, because tangency, by definition, has to touch it only at a single point. So this line that I drew, the red one, that is a line because there's rules that go along with tangency. And I'll show you what happens here. So from the center, and it's actually on the next page, straight to that will always create a right angle. It will always create a right angle. But I can't do that here for here. This would be a secant line, or it would be a chord that goes through those two. But I need tangency to only touch it at a single spot, otherwise it messes up my formulas. All right, now, did anyone actually come up with what this one is? Is that interior, right?
Yeah.
Okay, so just like we had right here in my notes, it is internally tangent circles. It's not the concentric circles, but these are internally tangent circles, and they're touching it at a single point right there. And this last one here. Daniel says no. I agree with him. I do, because
Doesn't touch.
they're not touching, right? And then they're not exterior, so I can't really even draw lines for them to touch because they're already, it would be going inside the circle. It could only be touching it one place on the outside because, again, we're going to have some rules coming up here in a moment having to do with some 90-degree angles. Does that make sense or no? Kinda? Yeah? Okay, good. So this next one right here is going to be the one I was talking about, where the tangent line, if a line is tangent to a circle, then it's perpendicular to the radius drawn, point of tangency. So from right there, that means that every time my radius goes to the edge and connects to a tangent line, a line that touches it only in one place, that's going to be a right angle. It is going to be a right angle. So I'm going to show you this neat thing right here. This first example, that is also a right angle. So given that, this is what type of triangle? It is a right triangle. It is going to be a right triangle, and every time we have with a right triangle, we have special things that always work with it. Because that is a point of tangency, the measure, this is what this means, the measure of angle A is 90 degrees. So you're going to put 90 degrees right there. There you go. So off to the side on your paper, we are going to do this, and I'm going to redraw it so you guys can see. This one is 7, right? 7.
24?
Yeah.
24, okay.
And right there. So we're trying to find this last measurement. This last measurement. When we have right triangles, we can always use my Pythagorean theorem, which is a squared plus b squared equals c squared. Do you guys remember any of that?
Yeah.
You guys had a little bit of it last semester, right? So Pythagorean theorem, a squared plus b squared is equal to c squared. Now, I am going to do the math for you to help you out. So in this case, c is always my hypotenuse. It's always the side, always across directly from the right angle. So I'm going to give you a new formula. I'm going to say that if I'm looking for c, that's equal to the square root of a squared plus b squared. And if I'm looking for the a value, which would be over here, and this one's my b, if I was looking for the a value, that would be the square root of c squared minus b squared. And if I was looking for the b, I would have the square root of c squared minus a squared. Yes, no, maybe? Okay, did you write these down? I hope so. Just off to the right. And if you want to write it on the line paper underneath, that's the reason why you guys have this as a foldable. You could write it as a line paper underneath and add to your notes. Yeah, we're going to do the math there. So now on this problem, we're looking for the c value, aren't we?
Yeah.
Yeah, we're looking for the c. So since I'm looking for the c, I'm going to say that c is equal to the square root of a squared plus b squared. So a, 7 squared, plus b,
24.
24 squared. And now comes to the part where I let you guys take out your phone
And go on TikTok. I'm just like,
NumWorks.
ain't that, man? Read it.
Okay, so we are going to go to NumWorks. Now, if you on the App Store, there is an app for NumWorks. There is a no, not those. There's an app for NumWorks. Do you have a smartphone?
Yeah.
On your phone.
Yeah.
Okay, whichever store you're going to, you're going to go find this app. It's called NumWorks. NUMWORKS. NUMW.
No.
NUM. Yep, that one right there. So NUM. Did you write it? Get it?
They're not working.
They are, but not for you. You have to be at least this tall to be able to use those calculators. It's not your race. No.
Yeah.
No. So how can I be racist if I hate on mature people? Is short a race? Short is a race.
Yeah, you say sure.
Wait,
Find
wait.
it. Okay, good.
You go back to the living?
NUM.
Huh? A las 10:30. O a las 11:30. Yeah.
NUM. N. Tommy. NUM.
Yeah, I need help.
WORC.
I
It's
need
muy
a number.
I'm gonna put the number there. Calm down.
Okay, why do that?
Are you coming around helping other people get on their phone?
Oh. Do you know?
I know you don't have your headphones in right now, right?
No.
So you can use. I know, but you got the NumWorks yet?
Why do that crazy stuff?
Okay, App Store.
No,
That's the App Store.
my brother.
Not the App. Go to your Play Store.
What do you got?
Store. Where do you get apps? Where do you download TikTok? Where do you download Instagram? If I wanted a game on your phone, where would I go? I was just there. Yes. The same as what's up there. Alright, you got it?
No.
Okay. Alright, so let's go ahead. I'm hoping everyone's got this by now.
No.
You didn't get it?
My internet is so slow.
Okay, so I still have to go through this, and you need to find a better way to actually do, yeah. Stop looking at TikTok videos. Killing all your internet. We are going to start with the square root, right? Square root on my calculator here. So it's going to be right here, square root. That's a square root symbol. And then my first number was 7 squared plus 24 squared.
Square root. Like that.
There we go.
No.
Hit. Bam. So what's my answer?
25.
25. So, my measure from point J to C, in this case, is going to be 25. See?
Yes.
What about JK? And KC? Now, how much is the radius? How much is the radius?
7.
It's from the center of the circle to the edge. If it's a circle, isn't that always the same no matter where we go? So therefore, JK has to be 7 because that's also a radius, isn't it?
How do we find 90 degrees?
The 90 degrees is up here. So right there, that's where we get that.
Yeah.
So if JK is 7, what do you think KC is?
25.
It's not 25.
Oh, it's 7.
Where'd you get that? Now, I'm just asking. You're on the right path though. The whole thing has to be how much?
25.
25. If this piece right here is 7, what would you do? Very good. And so 25 minus 7 is 18. There we go. See, I knew you got it. Just threw out the wrong number. There we go. All right, so I'm going to pause right here. I want you guys to start looking at some of your questions we have on the practice. So pause the notes.